I worry a lot about this section because if you haven't been exposed to it before, then you run into some issues with understanding what's supposed to happen. Okay, so absolute value, it turns everything inside the absolute value to a positive number. Okay, but when I solve for what's inside the absolute value, what I have is I have two situations. I have one when the inside of the absolute value is positive, and then I have the other case where the inside of the absolute value could be negative, but the absolute value bars turn it into a positive. Okay, so it's a two-step process when you guys solve these. And not to mention, we're going to also throw in some honors advanced math topics right now into this as far as writing your solutions are concerned. So first thing, and that is, I'm going to just solve a basic absolute value, right? So what can x be? X can be a number that is bigger than 5. Right? Or what happens if I plugged in a number that was less than negative 5 in for x? So if I had negative x is bigger than 5, so then x is less than negative 5. What if I plugged in like negative 6, right? Does this absolute value equation's inequality still work? Yes. So I plug in negative 6, it still works because the negative 6 turns into a positive 6, and then it's still bigger than 5. So when I graph this, negative 5, and 5. Okay. I'm graphing bigger than 5, and I'm graphing less than negative 5. So I always have two situations. One, when I just recopy down the absolute value, and one when I actually make what's inside the absolute value negative and I try to solve that inequality. So a couple things to remember is regarding graphing. When I graph, a closed dot is for less than or equal to or greater than or equal to. An open dot is for strictly less than or strictly greater than. Okay. Now there's another thing that I want you guys to do, which is write in interval notation, which we'll do in just a second. Do you guys have any questions so far about graphing these? So when I write an interval notation, I want to write, what interval notation is it shows me all the solutions I could possibly have. Okay, so I could have anything that is from negative infinity all the way to negative 5. But I cannot be equal to negative infinity, but I can be equal to 5. So it's going to look a little weird. I'm going to have a parentheses that stands for not equal to, and a little square bracket for anything that is equal to. Okay. And then I'm also going to go from 5, which I can be equal to, but I cannot be equal to infinity. What goes in the middle is a little u without the little curly part. Like a little Japanese teacup. But so what does this all mean? Hold on one second, Mason. So again, when I do I've been getting spam calls on my work phone, so I don't hook up I don't hook up my work phone to any devices. Okay, so interval notation. If I have parentheses, this is for less than or greater than. If I have square brackets, that's for less than or equal to or greater than or equal to. Okay, hold on one second. And the little u stands for or, meaning I could have something to the left or I could have something to the right. Okay, and the little bracket or parentheses goes to what I cannot be equal to. So I cannot be equal to negative infinity, which is why it's a parentheses, but I can be equal to -5, which is why it's a square bracket. Then I can be equal to 5, but I cannot be equal to positive infinity. All right, Mason, what's your question?
I was just wondering why the infinity sign had the
Huh? Why the infinity sign? Because I can't ever be equal to negative infinity or positive infinity. I can get close to it, I just can't ever be equal to it. Because technically infinity is not a number. Yes?
I was going to say, wait, if you put a negative sign on it, it's not really a number, but no, but I thought infinity was a concept.
So infinity is not a number, but we're going towards the a very large negative number, which is why we label it as negative infinity. Okay, so this is case 1 where I am greater than or equal to. So anytime I have absolute value where I'm greater than or equal to, I split it into 2 inequalities and I solve. And there will always be an or in between. Okay. Now, case 2 is when I have an absolute value and I have less than or equal to. This is where I write a weird type of inequality, okay? So I can still have the case where 8 can be negative, and I can still have the case where 8 can be positive, but I create a little sandwich where I put what's inside the absolute value in between 2 less than or equal to signs, and I'm less than or equal to the negative number, and I'm less than or equal to the positive number. There's nothing I can do anymore to this because x is already by itself. So all I can do is graph this. And I'm everywhere in between -8 and +8. So my interval notation almost looks like a coordinate point, except they have square brackets on them because I can be equal to it. This is where it gets a little strange, because if they were not equal to, it would look like a coordinate point. So you'd have to look at the context of the problem, right? So what's the problem looking at? The problem's looking at interval notation, so this is not a coordinate point. I'm looking at a coordinate point, then this is not an interval. Okay, so it depends on what you're actually looking at, even though they will look very similar. Okay. Questions? We'll do more. So, what does this mean? Absolute value, inequalities are really compound. Inequalities. Less than means and. So I could have anywhere between -8 and +8. Okay. Greater than means or. So that's why I have this little like U right here. It stands for one or the other. So I can be in either one side of that interval or the other side of the interval, but not both. Okay. My steps here. So if I do, let's see, 3, there's a lot of these. Like, let me try to remember. No, I don't want to start out super hard. I want to make sure if we do all the different types too. Okay, so if I look at 3, right, is this case 1 or case 2? Case 1 or case 2?
Case 1.
Case 1, because I'm greater than. So that means I'm going to have the absolute value of x minus 1 is bigger than 6. All I did is I just dropped the absolute value bars. I got rid of them all. Then I have another situation, which is or negative of x minus 1 is greater than 6. So all I did is I took what's inside the absolute value, I made it negative. So that's how I come up with my 2 answers. Most common mistake is that you only get one side, which is the first one I wrote down. You forget about the other side. Okay, so step 1 is to figure out what case you're doing. Step 2 is to separate them out. The way we separate them out is I copy this exact problem down without absolute value. Then I copy the exact problem down again, except I multiply what was inside that absolute value by a -1. And I solve. And I don't care how you solve. The right one, here's x is bigger than 7. I could either distribute that negative or divide by negative to start off with. I don't care which way you want to go. All of my answer keys, I wrote it as distributing. So I have negative x is bigger than 6, so that x is less than -6. So anytime I multiply or divide by a negative, I have to switch the direction of the sign. Sorry, it should be 5. Yeah, I figured when multiple hands went up, I made an arithmetic mistake somewhere. Oh my gosh. Questions about anything so far? So open circle at -5. I'm going smaller than that, so I'm going less than that. And then at 7, I'm going bigger than 7. Yes, Mason.
So there's different absolute values, because I remember that absolute value is how far away it is from 0. So if you had -6 absolute, that would make it just almost 6. So how can you know when you split it? Or you just
My center point changes when I'm doing something inside the absolute value other than just adding 0 and having a coefficient of 1. So essentially I shifted that center point so that you still have the same distance from the right and the left, but I had to shift it over by 1. So technically, right? This is my new center point. Because it was -1, I ended up shifting it over on the number line by 1. And so this distance here and that distance there are still the same. But my 0 point is not actually 0 anymore. I've shifted the entire inequality over. So when I write my interval notation, I cannot be equal to negative infinity. I also cannot be equal to -5. I cannot be equal to 7, and I cannot be equal to infinity. Questions that you guys have? For some of you, this is new. Right, some of you guys might have learned it a different way also. Most commonly missed question that I could ever test on is this. So you will see it on the quiz. And I don't think you see, I don't know if you'll see an inequality on the test. I don't remember. I feel like I didn't put it on there. Yes. Oh, because this is +1 here. So to get x by itself, I had to subtract by 1. Huh? Yes, because I did 6 minus 1 first, which is +5. But I had a negative here, so I had to multiply both sides by -1. Yes?
So if we have greater than or less than, will we ever see the equal to sign or not?
Yes, like we did in a previous section, yes. So they can get all jumbled up. Yes, Mason.
Alright, so when you're splitting up absolute value, I thought it was most of the time where, say like for number 2, if you split it up, 4 is either -4 or +4. So it's x is greater than or equal to 4, and x is greater than or equal to -4.
If you're going to do it that way, you have to switch the direction of the sign when you make it negative on the right-hand side.
Yeah, so
You can do it that way. That's not the way I'm showing you guys, only because nobody remembers to flip both of them. So I'm trying to eliminate steps where I think you guys are going to mess up. Okay, so what happens when I have case 2? So the less than situation is I have a -7. I copy what's down inside the absolute value, and then I have a +7. So I create a sandwich of x plus 2 in the middle, and the negative and the positive on the outsides, and they're both less than or equal to. When I subtract by 2, just like we did in that mathematics lesson, subtract by 2, I have -9 is less than or equal to x, which is less than or equal to 5. So when I subtract 2 from the middle, I have to subtract it from both sides of the inequality, not just one. So I get -9, I get a +5, and I get in between. So -9 to 5, and I'm closed brackets because I can be equal to it. Bless you. Questions? So what happens when, let's look at 9 and 10, because 9 and 10 kind of combines 5, 6, 7, and 8 together. one guy is the greater than the guy and one guy is the less than guy. So now we have both cases again. So when I have the absolute value not isolated, right? So I have this stupid little -2 floating around, right? I have to have the absolute value isolated first. So I have to get rid of this -2 first. And get the absolute value by itself before I determine what my cases are. When I multiply by a negative number, it does switch the direction of the inequality sign. Two greater than. Oh, I did 8. You should have stopped me. It's okay. We'll do 8. I guess I'm doing more now. Okay, so 4x minus 8 bigger than or equal to 12, or a negative of 4x minus 8 is bigger than or equal to 12. And Mason, back to your thing, I could have written this as 4x minus 8 is less than or equal to negative 12 instead. But you'd have to switch both of them, and I don't think people will remember that. Okay. Okay, so I go over here, I add 8 to both sides, so 4x is bigger than or equal to 20. Divide by 4, so x is bigger than or equal to 5. And then I have a negative 4x plus 8, so I do distribute my negative to both terms. Greater than or equal to 12, subtract 8 by both sides, so negative 4x is bigger than or equal to 4. Divide both sides by negative 4, so I get x is less than or equal to negative 1. So my interval notation is negative infinity to negative 1, union 5 to positive infinity. I'll skip 9 and do 10. 10's got fractions. I know. It's okay, we're going to get rid of them. You don't like them? Get rid of them. Questions so far? I will try, and I'm not trying to make any promises, but I will try my best to record a video for how to do half of your problem set and post that on the calendar also, so that you guys would be able to check your work for half of it. Okay. All right. Subtract 11. I'm going to get my absolute value by itself first. So 1/2 absolute value of 4x minus 4 is less than or equal to 4. I have to get my absolute value by itself, so I need to get rid of that 1/2. So I'm going to multiply both sides by 2. So the absolute value of 4x minus 4 is less than or equal to 8. This is now my case 2 situation. So I have a negative 8 less than or equal to 4x minus 4 less than or equal to positive 8. Create myself a little sandwich. Add 4 to everything. I get negative 4 is less than or equal to 4x, which is less than or equal to 12. Then I have to get x by itself, so I divide everybody by 4. So I have negative 1 is less than or equal to x, which is less than or equal to 3. So I have this little graph here. And I'm closed bracket at -1 and closed at 3. Questions that you guys have? If it is less than or equal to, then, or greater than or equal to, they're closed brackets, so square ones. If there's no equal bars, they're parentheses.